Hello, my name is Chuck Fox. My company is Power Safe Consulting. Already, we are an NFPA authorized education provider, and I am an approved instructor on the NFPA 70E standard. This recording is being submitted to the NFPA to seek approval to be an instructor for the NFPA 70B standard as well. So my topic for today is how to get started with an electrical maintenance program. And typically that is a question that has a lot of parallels to how to get started with an arc flash risk assessment, which has been a challenge of developing that throughout the years. The first order of business, of course, would be to establish the electrical maintenance program coordinator, and that's specified under Article 4.3.1. So the EPM coordinator, the EMP coordinator, ultimately is the individual responsible for coordinating the overall implementation and operation and ongoing success of the electrical maintenance program. To develop the program itself, there's a 6-step process that we can weave into the standards itself. And the first order of business of that is to develop a complete electrical system inventory and then embellish that inventory with the various aspects and requirements of the complete risk assessment of the various other studies and such, and additional requirements of data elements needed to do an ongoing management of the electrical maintenance program. 4.2 of the 70B standard is the section that discusses an entire listing of various elements of the electrical maintenance program, and we'll be weaving several of those into our discussion as we again answer the question of how to best get started to develop the electrical maintenance program overall. So the first order of business of that is to survey and complete an analysis of the electrical equipment and the systems for the purpose of establishing maintenance requirements and establishing priorities. The term survey is also defined within Chapter 3 definitions of 70B as the collection of accurate data on the electrical system and the evaluation of this data to obtain the information necessary for developing and implementing the electrical maintenance program. So the question then is, what data should be collected and how will we document and record that data? Well, an element of the electrical maintenance program says that we need a records retention policy for the maintenance, the equipment, and personnel documentation. That's an interesting way of looking at it because the 70B standard does not articulate any particular type of software or collections of various systems and processes that an organization may have. So how will we go about recording the data, and what data that needs to be recorded is the core question. And then we can apply that out to either specific software for managing the electrical maintenance program or a composite of various other systems and procedures and processes already in place within a company. The 70B standard remains neutral on any of the type of tools used, but is clear about having documentation and record management policies related to the maintenance, the equipment, and personnel as well. So data collection beyond the elements of the attributes of the electrical components themselves will also include the additional information needed for the various system studies as outlined in Chapter 6. So specifically, the short circuit study, the coordination study, and the arc flash study are information that is typically been provided historically within an arc flash study. And now we have the additional studies of reliability and load. So combine those may and do create additional data elements needed in order to be merged with the existing electrical system inventory data as an overall composite data set needed to, again, manage the overall electrical maintenance program. A best practice, of course, when we talk about that initial survey is to ultimately include in that survey what components are tasking. Of course, a best practice begins with using infrared thermography as a testing survey, and that's actually documented as an element within the maintenance interval table under Chapter 9.2.2. It basically says that all information shall be tested with infrared thermography for an interval not to exceed 12 months. Today, however, though, we also can take a look at Chapter 7.4 of 70B, and it talks about infrared protocol or tasking practices. These would include the removal of protected covers so the infrared camera has a clean line of sight, the documenting of load readings, and the identification of any particular problems as identified with heat signatures based upon the survey and scans of the electrical equipment. There's been various aspects of that's been done over the years. And one other very positive approach to that would be to basically have baseline IR images to say that each and every component has its own IR test, whether it's been tested as clean and good or whether there are problems as well. We also can expand this survey to include what I'll call other metrics of condition of maintenance. And again, 70B gives us some structure and direction on that. 4.2.2 talks about an inspection. And basically, this inspection is a review of the electrical system to assure that it is in compliance with the installation codes and standards. And here we're referencing in the NFPA electrical cycle of safety, the results or the components and structure of NFPA Article 70, the National Electric Code. 4.2.3 condition of maintenance will look for other types of visual inspections and reliability concerns and issues in order to again address this overall result of electrical components and assessment of their condition of maintenance. And again, in review, the other additional component for the electrical maintenance program would be its entire problem reporting, corrective action, and definition process of how various anomalies within the electrical system shall be documented. So the various tasking that's done on that to achieve these broader sets of requirements beyond infrared thermography would be visual inspections looking for reliability issues, elements not meeting NEC standards, and other deficiencies. So a key decision by the electrical maintenance program coordinator, the EMP coordinator, would be who does this data collection, what are the tools in place to do it, and how it will fit into achieving the overall goal of, again, getting an EMP program up and running. Additional elements that the 70B standard would call for is, I'll call it additional field definitions. One of them, of course, is the physical condition rating, because that's a key element within the operation of Chapter 9.2.2, the entire maintenance interval discussion. So we need to establish a place to document that for every component within the electrical maintenance inventory. And essentially, there's an additional field that would be a companion field with that, to talk about various maintenance comments. So any time that the maintenance intervals would deviate from the various standards put in place, various comments are indeed documented as a requested element to document those deviations as well. The arc flash labels or arc flash study becomes one of the other core foundations of our electrical maintenance program, because it will deliver the safety aspects needed in order to go to work and actually do tasking and implement the various maintenance protocols. One way to tie that back in is that the electrical maintenance program, first of all, is already by the 70B standard tied to the electrical maintenance safety program as outlined under 70E Article 110. So the electrical maintenance program shall be designed to function in conjunction with the various parameters of the electrical safety program. One of those, of course, is the job safety plan or job safety analysis, and the required elements of the job safety analysis relies heavily on the data information gathered and provided within the arc flash labels. So a key project requirement and starting point, as we talk about, is really a decision on this records management and retention policy or practice. How will we go about not only collecting the data, but what type of various structures are we going to use to capture that data? And again, the various aspects of how all of these different elements come together to give us the result of a complete electrical system inventory. So the article written in ECNM magazine in May of 2025 outlined these 6 steps, and today we covered these 2 as part of this demonstration tape. Well, thank you for your time, and I look forward to your assessment.